Good morning, everyone. This is the final part for the chapter 1 videos, where we are going to discuss about the examples for the one that are used in the module. Hopefully the explanations will make you understand better. So without further ado, let's begin. Alright, so the first examples that we are going to discuss here is a sample containing 4.20 gram of titanium is burned with excess air to form titanium 4 oxide. Write a balanced chemical equation for the combustion of titanium to form titanium oxide. So as you have already learned that when metal burns with oxygen, you form metal oxide. So in this case, they already give you the formula of the titanium, which is TiO2. So all you have to do is just write out the balanced equation. If possible, try your best to memorize the state of matter. Okay, so in this case, titanium is solid, oxygen is gas, titanium oxide is solid. So most of the time, metal oxide are solids. So B, calculate the theoretical yield of titanium oxide formed from the amount of the sample burned. So which is, you have to first calculate the mole of the titanium, which is mass over atomic mass. So you get 4.20 divided by 47.9, you get 0.08768 mole. Then you compare stoichiometrically from the equation in here. So you see from the equation in here, 1 mole of titanium is to 1 mole of titanium oxide. So therefore, the mole of titanium oxide is also equals to 0.08768. So therefore, the mass will be equals to mole multiplied by the molar mass. So 47.9 times 2 times 16. So you get 7.01 gram in 3 significant figures. And then finally, determine the percentage of yield if 5.28 gram of titanium oxide is produced from the amount of sample burned in laboratory. So you use the percentage of yield is equals to actual yield divided by theoretical yield times 100. So you get 5.28 divided by 7.01 times 100%, you get 75.4%. Right? First examples. So we're going to have a look at the second examples. So you have TNT, which is used as the explosive, can decompose according to the following equation. So you have two of such compound. Actually, this compound is named as 2,4,6 trinitrotoluene, TNT. So you get 7CO plus 7C plus 5H2O plus 3N2. Now, some of you might started to question. So we haven't learned about this in organic chemistry. How would you know the formula? Actually, you can eventually tell the formula because according to the law of conservation of mass, the total number of atoms in the left side must be equal to the total atom at the right side here. Okay, so if you calculate accordingly, you can see that you have 7C and 7C, so total is 14C. Then you have 7O in here. Then you have 5O, so total is 12O. Okay, and then you have 5H2, so total is 10H. And then you have 3 and 2, total is 6H, 6N, sorry. So out of these two of this molecule, so you have this 14 carbon, 12 oxygen, 10 hydrogen. So one of these TNT is equivalent to how many carbon? Okay, 7 carbon, 6 oxygen, 5 hydrogen, and 3 nitrogen. All right, so based on this, we can start to calculate the relative atomic molecular mass of the TNT. So you have 7C, so you have 7 times 12.0 plus 3 times 14.0 plus 5 times 1.0 plus 16 times 6.0. So you get 237. B, what is the volume of gas produced at 25 degrees Celsius? Now, this is a very dangerous trap here. You have 25 degrees Celsius with 1 atmosphere when 10 grams of TNT exploded. Okay, so why do I say that this one is a trap? Because if you look at the equation, this is a gas, this is a gas, this is also a gas, but specifically this one mentioned at 25 degrees Celsius. So water is actually liquid under room temperature pressure. So basically, 2 mole of TNT will produce 10 mole of gases if you look carefully. Okay, so mole of TNT is equals to 10.0 divided by 237. So you get 0.04405. So since 2 mole of TNT is equals to 10 mole of gases, so mole of gases is equals to 0.04405 times 5, you get 0.2202. So volume of the gases multiplied by 24.4, so you get 5.37 decimeter cube. Okay, then we go for number 3. Sodium phosphate is often used as a water softening agent. A sample of sodium phosphate was prepared by reacting 50 centimeter cube of 0.5 mole per decimeter cube of phosphoric acid with sodium hydroxide. Write a balance equation for the complete neutralization here. So you use H3PO4 plus 3NaOH, give Na3PO4 plus 3H2O. Calculate the mole of H3PO4 used in this reaction. So use MV over 1000. So you get 0.500 times 15.0 times over 1000. So in this case, you have to substitute as exactly given to you in the questions. Yeah. So you get 0.25 and hence calculate the volume of the sodium hydroxide at concentration 0.325 required for the complete neutralization. So in this case, there are two ways that you solve here. So you use 1 mole, so you calculate the mole of sodium hydroxide. Then you use the volume to calculate the volume here. Or you can also use the formula MAVA equals to A over MVDB equals to B. Okay. So your concentration of the sodium phosphate phosphoric acid is 0.500 times 50.0 over this 0.325 divided by dp equals to 1.3. So yes, also you can also probably get the same answer as in this one here. Okay. Okay, so that is how we are going to solve question number 3 in here. Okay, so number 4, when the 0.100 sample of urea-based fertilizer was boiled in excess NaOH, the following reaction took place. The gas evolved, was absorbed in water, and the resulting aqueous solutions titrate with hydrochloric acid. 14 centimeter cube of 0.200 HCl were required for the neutralizations. What is the percentage of nitrogen in this sample of the fertilizer? So first of all, you need to calculate the base of the equation, NH3 plus HCl give NH4Cl. So mole of ammonia is equivalent to mole of HCl. So mole of HCl is 0.200 times 14 over divided by 100. So it gets 2.8 times 10 power negative 3. So mole of urea is equals to half of the mole of the NH3. Why? Because the chemically 1 is to 2 in here. So that's why you have to divide by 2. So you get 1.4 times 10 power negative 3. So since 1 mole of urea contains 2 mole of nitrogen, so mole of nitrogen is equal to 2 of the mole of urea. So you get 2.80 times 10 power negative 3. Then calculate the mass of the nitrogen. So 2.80 times 10 power negative 3 multiplied by 14. So you get 0.392. And for the percentage, you divide by 0.100 gram times 100%, you get 39.2%. So that is basically how you're going to solve number 4. Number 5, chlorofluorhydrocarbon, HCFC, could be used to replace chlorofluorocarbon, which are believed to be responsible for destruction of the ozone layer. One typical HCFC with the molar mass 138 has the following percentage composition mass. What is the empirical and molecular formula of HCFC? So as usual, you're going to create the tables which consists of the mass as 100%. Then you divide it by the respective atomic mass. So 18.8 divided by 12.0, 1.5 divided by 1.0, 52.6 divided by 35.5, and 28.1 divided by 19.0. You get 1.56, 1.55, 1.48, and 1.48 respectively. So when you divide by 1.48, you should probably get more or less of the same ratio, which is 1 to 1 to 1 to 1. So your empirical formula is CFClF. So this CHClF factorized by the factor n is equal to 138. So you sum up all the molecular mass for the empirical formula, multiply by the factor n equals to 138. So you get your n is equals to 2. So your molecular formula will then be C2H2Cl2F2. So that is how you are going to solve for question number 5. Number 6. 10 centimeter cube of hydrocarbon A will mix with 40 centimeter cube of oxygen in an excess and explode. After cooling the apparatus to room temperature and pressure, 30 centimeter cube of gas that was remain will be shaken with an excess potassium hydroxide. So 20 centimeter cube of the gas remain. 1. Write your balance equation for the complete combustion of hydrocarbon with the formula CXHY. So the formula will be CXHY plus X plus Y over 4 with X CO2 plus Y over H2O. So I will briefly describe what is going on here. So in here, CXHY means that 1 mole of the hydrocarbon will contain X amount of C and Y amount of hydrogen. So X amount of C will produce X amount of the carbon dioxide because stoichiometrically is 1 to 1. Whereas Y amount of H, because one water is made of H2O, so you produce Y over 2 of the H2O here. Okay. Now, at the same time, when you produces carbon dioxide, you also will make use of the water, oxygen, isn't it? So if you produces X amount of carbon, produces X amount of carbon dioxide, so at the same time, you use X amount of the oxygens in here, isn't it? As for the hydrogen, since Y amount of H produces Y over 2 amount of the H2O, so you have Y over 2O. So Y over 2O is equivalent to how many O2? So you have Y over 4 O2. Okay, so that is how you can formula X plus Y over 4 O2. Number B, name the gases in 20 centimeter cube that is remain at the end of the reaction. So from the formula in here, you say that initially you have 10 centimeter cube of hydrocarbon burned with 40 centimeter cube of oxygen. So after burning, so no more hydrocarbon left, you have A plus B amount of the 30 centimeter cube. So after pass through by KOH, so you have to know by yourself that potassium hydroxide is used to absorb carbon dioxide. So in other words, 10 centimeter cube of carbon dioxide was absorbed by CO2. So the remaining 20 centimeter cube in A is oxygen gas actually, the excess oxygen. C, name the gas produced by the combustion that will react with aqueous hydroxide and calculate the volume of this gas produced. So when passed through, 10 centimeter cube will 10 centimeter cube of carbon dioxide is absorbed here. Calculate the volume of oxygen used after combustion. So volume of oxygen used is equal to volume of oxygen unused minus volume of oxygen unreacted, which we already deduced in B just now. So you have 40 minus 20, you get 20 centimeter cube. Hence, determine the molecular formula of A showing all your groups. So you have CXHY plus X plus Y equal 4 give XCO2 plus Y equal 2 H2O. So at the end, you have 20 centimeter cube of the oxygen. That means 10 centimeter cube of the CO2. So therefore, the ratio is 1 to 2 to 1. So since one carbon, CXHY produces one carbon dioxide, therefore you have your X is equals to 1. Since X plus Y over 2 equals to 2 and X is equals to 1, so Y over 4 is equals to 1, therefore Y is equals to 4. So therefore your molecule of hydrocarbon A is CH4. Yeah. Okay, so this is for number 6. And finally for number 7, now this is the high levels solving for the empirical formula. 1.367 gram of the carbon of an organic was combusted in a stream of dry oxygen to yield 3.002 gram of carbon dioxide and 1.640 gram of the water. If original compound contain carbon, hydrogen, oxygen, what is the empirical formula? Okay, so before we go for the explanation, one thing that you have to understand, when we have 1 mole of carbon produces 1 mole of carbon dioxide. Isn't it? So can you accept if I say that 12 grams of the carbon will produces 44 grams of the carbon dioxide? So basically, you just multiply by the relative molecular mass here. So carbon, which is 12, this one is 44. Okay. For the water, we say that 1 mole, 2 mole of hydrogen atoms will produce 1 mole of water. if you multiply, if I say that 2 grams of the hydrogen is equivalent to 18 grams of water. Okay, so because this one you multiply by 2, which is the 2 times 1 RMM here, which is RMM of water, which is equals to 18. So that is the concept in here. So in this case, because you have the mass of the carbon dioxide and you have the mass of water, we just basically use the ratio methods here. Okay, so if you can understand, then very good, right? So it'll be easy for you to deal with what I'm going to explain here. So as we have already described just now, so since one carbon dioxide is to one carbon dioxide, one carbon for one carbon dioxide, so x divided by 12 equals to 3.002 divided by 14, you get 0.8187 gram. So 2 hydrogen produces 1 water, so y over 2 is equal to 1.640 divided by 18, you get 0.1822 gram. And then don't forget you also have oxygen, so you minus off from the total mass, so 1.367 minus 0.8187 plus 0.1822, so you get mass of oxygen is 0.3661 gram. So you build back the tables where you have the mass, you cover the mole, so mole of the carbon is equivalent to 0.8187 times 12, you get 0.0682 gram. 0.1822 divided by 1, you get 0.1822, and then 0.3661 divided by 16, you get 0.0229. So at the end, you get your ratio is C3H8 and also O, and therefore the empirical formula will be C3H8O, right? Okay, so I hope you are able to understand of what I have already explained from the examples in here. So beginning next video, I will start with the chapter 2 explanation, right? So see you all in the next video. Thank you very much.